Hey guys, let's have a look at Assessment 7, which goes over areas, perimeters, volumes, and surface areas. Now, if this is your first time through this assessment, feel free to hit pause at any time to work through the questions on your own, and the answers and explanations will come at the end. And of course, if you're finding that you need a bit more than just practice on this, you might want to have a look at the links I've posted down below for the lessons that we've done on these topics. All right, let's get started. First, we've got an area question, the area of a triangle and the area of a composite shape, and some comparison of those areas. Here we've got the area of a trapezium, but you need to rearrange that area formula to find the length of the base. Perimeter and area of this parallelogram. Rearranging area formulas, here we're talking about the area of a triangle. Perimeter and rearranging area formulas, here we're talking about a rectangle. The volume and surface area of this rectangular prism or cuboid, and areas of trapeziums and volumes of prisms. This is a trapezoidal prism. Okay, so are we ready to take that up now? Let's get started. First with this area question. For the triangle, I'm hoping that will be easy. You should know the formula for the area of a triangle is base times height divided by 2, and the base and height are clearly labeled. The base is 7, the height is 6, so that's 7 times 6 divided by 2, which will be 42 divided by 2, which is 21 centimeters squared. Our base and our height were in centimeters, so our area is in centimeters squared. Next, for this composite shape, you should be thinking about breaking this shape down into parts. So I've got the full composite area will be equal to the area of shape A plus the area of shape B. Now, you could split this however you like, but I split it this way because here I can clearly see that A has got a length of 4 and a width of 11. Those are given to me, so I don't have to worry about working out what this length in here is or what this length across the bottom is. And for rectangle B as well, I can see 3 and 4 are my measurements. So working out my area A plus my area B, I'm doing length times width because they're both rectangles, 4 times 11 for A, and 4 times 3 for B. So that's going to be 44 plus 12, which is 56 centimeters squared. Once again, all of my measurements were in centimeters here, so my area is going to work out to be in centimeters squared. Now, true or false, the triangle is less than half the area of the composite shape. Look at the area of the triangle, look at the area of the composite shape. Half of 56, that would be 28. And 21 is definitely less than 28, so this is true. Write the area of the triangle as a simplified fraction of the area of the composite shape. So let's see if this area of the triangle over this area of the composite shape really is less than half. So I'll set up that fraction, the triangle area over the composite area, and I get 21 over 56. Now I don't know if that's the same as a half or less than a half or more than a half. I can simplify it down a little bit. That's 3 over 8, dividing both the top and the bottom by 7. And 3/8 is less than a half because I know that half of 8 would be 4/8. So 3/8. Next, rearranging this formula. Here we are given the area of the trapezium, and I know that the formula for the area of a trapezium is A plus B divided by 2 times H. For anyone who's having trouble remembering that, you should be thinking this is the average of the parallel sides. I want to do base times height, but I've got a different length for the base as I do for the top length. So I average these out, this plus this divided by 2, and then I times by the height. Right, and we're told that this has a total area of 147 centimeters squared. So I'll use this formula and I'll set it equal to the value that we're told that it has, and that will make an equation we can rearrange to solve. So substituting into this formula, I knew that the top length was 9, so I've substituted that for A. I don't know what the base is, so I just put B there. And I know that the height is the 7, not the 18. Please don't get that confused. The height is the perpendicular distance, so at 90 degrees here, between the parallel sides, so the 9 centimeters and this base. So rearranging that to find out what B is, I want B on its own. Right now B is being added to 9, then divided by 2 and multiplied by 7. So my first step will be to take the 7 across, and the opposite of multiply is divide. Now I want to get the b on its own. Remember, it's being added to 9 and divided by 2. So my next step will be to take the 2 across, and opposite of divide is multiply. Now I want the b on its own. The only thing I need to get rid of is the 9. The 9 is adding to the b. So I'll take that to the other side and I'll subtract. So b must be 33 centimeters. You can always check your answers, and you should check your answers, especially on an assessment or test or quiz. If I know that the base is 33, go ahead back up here and plug 33 in. 9 plus 33, that would be 42. 42 divided by 2 is 21. And 21 times 7, does that give you 147? It should. Okay, so our base is 33 centimeters. Onto this parallelogram. So to work out the perimeter of the shape, please don't get confused with all these measurements here. 5 is not one of the outer sides of the shape, so ignore that 5. The perimeter of the shape is going to be the sum of all the outer sides, which is 15, plus the 15, plus the 7, plus the 7. That gives us 44 centimeters. The area of the shape, however, involves the base and the height. Remember, 7 is not the height, it's not at 90 degrees to the base, so ignore the 7. The base is 15 and the height is 5. So 5 times 15 is 75 centimeters squared. Next, we have another rearranging formula for you. You're told that to work out the height of the triangle with a base of 8.5 centimeters and an area of 59.5 centimeters. Anytime they give us a value in a question, you should be thinking about using the formula that we need to find out that value. So given the area is 59.5, the area formula for a triangle is base times height divided by 2. That must mean that base times height divided by 2 is equal to 59.5. So let's set that equal to 59.5 and substitute into that formula. We know that the base is 8.5. It's given in the question. So base 8.5 times height divided by 2 is equal to the 59.5, the area we were given in the question. We want to find out what the h is, so to get it on its own, think h is being multiplied by 8.5 and divided by 2. The first thing I'll move is the last term I said, so move the 2 first. It was divide, so I will multiply. So 59.5 times 2, that's 119, and to get the h on its own, I've moved the 8.5, it was multiplying, to the other side and divided by it. That gives me my height of exactly 14 centimeters. Again, you can check your answer. Once we've got the height, we can go ahead and plug it back into the formula here and do base times height divided by 2. Does that give us 59.5? 8.5 times 14 divided by 2 should give you 59.5. So our height is 14. Next, perimeter and rearranging an area formula. Again, they gave us the area this time. A rectangle has a length of 5.2 centimeters and an area of 23.4 centimeters squared. So they give us the area. We set up the area formula for this rectangle. The area of a rectangle is length times width. So I'll substitute the values that I'm given in the question into this formula, and I'll rearrange to figure out what the width is. I know that the area is 23.4, and I know that the length is 5.2. Let's get W on its own here. So let's rearrange. W is being multiplied by 5.2. Let's divide by 5.2, which will give us the width, which is 4.5 centimeters. Again, you can check that. We could go ahead and plug that width back into the equation and say 5.2 times 4.5. Does that give us 23.4? You should always check whenever you can. Next, the perimeter of the rectangle. The perimeter we know for any shape is the sum of its outer sides. For a rectangle, that's 2 lengths plus 2 widths. We know the length is given in the question, 5.2, and the width we just worked out is 4.5. So 2 times 5.2 plus 2 times 4.5. That gives us 10.4 plus 9, 19.4 centimeters. Now, volume and surface area. This is our new material for this week. And mostly we've just been looking at the volumes and surface areas of rectangular prisms like this one here. But I have warned you to be careful not to just generalize and think that all prisms have the same volume and surface area. It's not always going to be length times width times height for a volume. So I've shown you the correct formula so you can apply it to any type of prism. In this case, we're told the length, the width, and the height of this rectangular prism. Now, it doesn't tell you which is which, so I've just labeled them on here. Length is 8, width is 7, and height is 4. Although maybe you thought height shouldn't be going backwards like that, height should be going upwards. So maybe you've labeled it like this. Length is 8, height is 4, and width is 7. Or maybe you even labeled it like this. Width is 7, height is 4, length is 8. In the case of a rectangular prism, it doesn't matter how you've labeled it. That's why we're starting with rectangular prisms. The volume of any type of prism is always going to be the cross-section area times the length of the prism. And it's up to you to figure out which face is going to be the cross-section face so I can find the area of that face. In the case of a rectangular prism, it doesn't matter which face you choose as the cross-section face. But if I'm going to use the formula for the area of the cross-section face, and all of these faces are rectangle, if I'm going to say that that's length times width, I'm going to say that this top face is my cross-section face. Because here I can see that for this rectangle, length is 8, and width will be the same as this width that I've labeled down here. Width will be 7. And the length of the prism, or the distance between the two cross-sectional faces, so this face here and the identical face on the opposite side of the prism, that distance will be equal to the height, which is 4. Now I know a lot of you have generalized your formula for the volume of a prism, and you think that it's just always going to be length times width times height. That is only the case for rectangular prisms because the cross-section area is a rectangle, so it's going to be length times width. In the case of a triangle, as we discussed, it wouldn't be length times width, it would be base times height divided by 2. Okay, so making that clear, let's go on. With this rectangular prism, our area of the cross-section, so this area here, is going to be 8 times 7. And then we multiply that by the distance between this cross-sectional face and the identical cross-sectional face on the opposite side of this prism. That's 4 centimeters away. So length times width times height, 8 times 7 times 4. That's 224 centimeters cubed. Note that every measurement in my calculation was in centimeters, and we're talking about volume, a 3-dimensional measure, so it's in centimeters cubed. Next, let's look at the surface area of rectangular prisms. And again, I've shown you the formula that works for any type of prism, but you need to adjust the formula depending on what type of prism we're looking at. Here we're looking at a rectangular prism, so the surface area is going to be 2 times the cross-sectional area. It's a rectangular prism, the cross-section is a rectangle, we use that formula for the area of the cross-section, plus the big combined rectangle area. For this, you may want to go back to our lesson on volumes and surface areas if you don't remember it, but let me show you what the net of the shape looks like. There I've got my 2 cross-sectional faces at the top and at the bottom if I folded them out flat. And if I show you all of the other faces, so this face, for example, is here in light blue, this side face is here in dark blue, then the back face, which we can't see, is in light blue, and the other left-hand side face that you can't see is in dark blue. So the big combined rectangular area is all 4 of these together. And to find the area of that one big rectangle, we need to know what this whole length is, which is made up of 4 different parts. But those 4 parts correspond to the 4 sides of the cross-sectional face. So this is going to be equal to the perimeter of the cross-sectional face because it will wrap around the cross-sectional face when I fold it back up to make this rectangular prism. So to adjust this formula specifically to rectangular prisms, I'm doing 2 times the area of a rectangular cross-section face, and I'm adding the perimeter of the cross-section face times by the distance between these cross-sections. So the distance between these cross-sectional faces, the distance between these yellow rectangles I have here, is going to be equal to the height of that prism. Okay, so let's substitute our values into this so that we can see what it's going to be. 2 times the area of that yellow rectangle is going to be 2 times, remember this is 8 and this is 7, so 2 times length times width is 2 times 8 times 7, plus the perimeter of the cross section, so 8 plus 7 plus 8 plus 7, that's going to be this length here, 8 plus 7 plus 8 plus 7, that's the full length of that big combined blue rectangle I've got there, multiplied by, what's this length here? Look on the folded up rectangular prism, this is 4. So 8 plus 7 plus 8 plus 7 times 4, that's the area of the big blue rectangle. And this works out to be 2 times 56 and 30 times 4. These two rectangles both have an area of 56, and this big blue rectangle here will be equal to 30 multiplied by 4. So that gives us a total of 112 for my 2 yellow rectangles and 120 for my one big combined blue rectangle. Total surface area will be 232 centimeters squared. All of my measurements were in centimeters, and surface area, as you see I folded it out flat here, is a 2-dimensional measure. So that's centimeters squared. Right, last question here, the area of a trapezium and the volume of prisms. Any kind of prism, not just rectangular prisms. That's why I've been so careful this week to point out that rectangular prisms are a special type of prism. The formula for each type of prism might be slightly different, but the theory is the same. So for a rectangular prism, we find the area of the rectangular cross-section, and we multiply it by distance between it and its exactly congruent same shape and size face on the opposite side of the prism. For a triangular prism, the volume is found by finding the area of the cross-sectional face, in this case a triangle, and multiplying it by the distance from that triangular face and the identical triangle face on the opposite side of the prism, hidden back here. Even for this type of prism, this heart-shaped prism, to find the volume, I would find the area of the heart, and I would multiply that area by the distance from that front cross-sectional face and the identical cross-sectional face that I have at the back hidden here. Now, of course, I would never ask you to work out the volume of a heart-shaped prism if I didn't first tell you how to find the area of the cross-section, the area of the heart. But you do know how to find the area of a triangle, you do know how to find the area of a rectangle, and you do know how to find the area of a trapezium. So let's get started. We all know the formula for the area of a trapezium is the sum of the parallel sides divided by 2 times by the height. Remember, that's the average length of the parallel sides. So that's going to be 5 plus 7 divided by 2 times by the height of the trapezium, which is at perpendicular to the base. That's 5 centimeters, not 12. So that's going to be 12 divided by 2 times 5, which of course is 6 times 5, which is 30 centimeters squared. So we know our trapezium face is 30 centimeters squared. So onto the volume of this prism. It's the area of the trapezium face multiplied by the length of the prism. So that's going to be the 30 centimeters squared we just worked out, multiplied by 12. 360 centimeters cubed. Again, remember, all of our measurements were in centimeters, and this is now the volume, a 3-dimensional measure, so our answer is in centimeters cubed. Now, if you found this assessment particularly difficult, you're going to want to have a look back at the assessment we did last week, that's assessment 6, and the video that we did for the preparation for Assessment 6, and you'll see that they were very, very similar. Most of the questions are almost the same, apart from, of course, these new questions on volumes and surface area. Okay, I hope that helps, and good luck with your studying.